Two. Today we're talking about strings. We've used strings. We've seen strings from day one. Playgrounds began with a string. What does a string look like? If we have a string message, define a literal string. When I say literal string, I'm talking literally between the quotes. You're asked to define a literal string. Literally, it's between the quotes. So between the quotes here, you put your message. Good morning. iOS 6.3. That's a literal string. So declaring and initializing a literal string. A lot of angels. Okay? We've seen loops before. We saw loops today. We saw loops yesterday. You could loop through a string because a string, by definition, is a collection of characters or Unicode compliant characters, right? It's a collection. The string is made up of a collection of Unicode compliant characters. We'll see what a character looks like. We'll see what a Unicode looks like. I'll just put those names down as we go through it. Vocabulary. So far I've mentioned Unicode. We'll see what that means. We've seen character. Okay. We spoke about literal strings. Example, this is a literal string, hello. Literally between quotes. So here we're declaring and initializing a literal string. It says, good morning, iOS 6.3. What does it mean when we say, or we define a string to be a collection of Unicode compliant characters? We'll use a for loop to loop through the string and see what that looks like. So we'll use a for loop. We'll name our variable char, or character for short. Character in message. So for each character in the message string, right, we'll print what the character is. So print character is, using string interpolation, we'll say char here. We'll run our playgrounds. I'll scroll up a little bit. And we'll see each character has its own line, right? Character is G. G is the first character in that particular message. We also see space. I said space is also a character. Space is a Unicode character. Everything that makes up that string is a character. We could count how many characters we have in the string. Print how many characters we have. So message count is, using string interpolation, we could declare or specify how many characters we have in there, or the count of the string. And here we'll say message dot count. Count is a property. We've seen functions. I think that's the first use case where we see a property, if I'm not mistaken. So here we have message.count. What does that say? It says, hey, give me the count. How many characters do you have in this message string? So let's go ahead and run it. Yes, sir. So here we see message count is 20, right? If we were to count each character in that particular message, we'll get 20. Let's start out with an easier one where we could see it easier. Let's have good and see how long good is. So good is 4. That's the length of the string. Everybody with me? Count is, so as Melinda is asking, count is not a function. Count here is a property. We'll see properties more in the unit. We'll talk about properties and functions. But in that case, message has string, has a property on it called count. So on any string, you could say, give me the count. Right? On any string, I could say, give me the count. I could say on Melinda here, I could say on a literal string, Melinda, that count. That's valid. Right? And if I was to run the playground here, it will tell me 7. Everybody with me? On any string, whether it be a literal string, any string you have, you could say, hey, how long is this string? In that case, Melinda is 7. That's the length of it. If you count the characters, it's 7 characters. So far, so good? So we've seen a literal string. We had our good morning earlier. The count? No, you could also do it on arrays as well. But we'll see it as we keep going. But you could also do it in arrays. Like I have some array, that count, it tells you how many objects, how many items in the collection. So good morning, iOS 6.3. Great. Okay, so we've seen counting or length of string using the count property. We've seen how to iterate or loop. Oh, sorry, let me close the console so we have more space. So we've seen how to iterate, means looping, right? Iterate or looping over a string using a for in loop. Okay. String is one of the most fundamental structs, objects in Swift or any programming language, right? It enables us to put messages throughout our application, interact with content from the user. Interviews are heavy on strings, right? So knowing strings is very fundamental to acing an interview. I think 80% of interviews ask string-related questions along with arrays, right? So those are the big topics that we really have to grasp and know. Okay. So we spoke about Unicode earlier. Let's get into that. So here, let's talk about Unicode. Another function is a property. Yeah. Did you finish type? Okay, cool. Cool. So let's talk about Unicode a little bit. Okay. So Unicode basically enables us to have multiple languages in the world. Unicode is an international standard. It allows us to have, as I said, multiple languages in one standard. So I could have Chinese characters, German characters, Scandinavian characters, emojis, which we like to send. All that makes up Unicode, right? So anything I could have in Unicode, I could have in a string. As I said earlier, a string is a collection of Unicode compliant characters. So everything in a string has a Unicode representation. A space has a Unicode representation. So a string, for example, in Unicode, a space in Unicode is represented by U plus 0020, right? That's the Unicode representation of a space. lowercase a, uppercase a, t, a tilde, all those have Unicode representations. The basis of the string structure is made up of Unicode, right? It's very flexible. We could do a lot of things with strings. We could define a character as one or more Unicode scalars. We'll see what a Unicode scalar looks like. But basically, that's a character. So a lot of things are happening here. We have a character. Strings are made up of characters. Characters are made up of Unicode scalars. Right? There's a lot there. A character, oh, sorry, my H disappeared. A character is made up, let me fix that. A character is made up of one or more scalars. We'll see what a scalar looks like right now. So if I have, for example, if I want to put an accent on my letter E in my name, so if I have my name here, name is Alex, right? And I want to put a character accent on the E, there's a Unicode representation for that. Let's first print what my name looks like. So name is just Alex, as is. Well, I didn't print name, but name is in our preview, right? So Alex is as Alex is. If I want to go ahead and use Unicode, as I said, strings are characters. Characters are made up of Unicode scalars. This is a Unicode scalar. This is the syntax for a Unicode scalar. Backslash. The U symbol indicates Unicode. Open curly, close curly. So this here is the syntax for Unicode. This is the syntax for Unicode. And as I said earlier, whatever number it represents that specific character, you put it within the curly bracket. In my case, I want the accent on the E. So it's 301. I'll go ahead, I'll play my playground again. And now we see on my E, there's an accent. Do we see that? Everybody? So any representation of characters, Unicode, that you want, is available for us. Unicode is bigger than ASCII. If we've seen ASCII, ASCII also has representations for characters, but ASCII became saturated. The languages that we have in the world, there's just too many languages. Too many languages for ASCII to support them. So we have Unicode, which has, for now, think about it as limitless, although it's not, but there's a variety of emojis. We see emojis coming up every day, right? There's a bagel emoji, right? There's always people like, oh, that doesn't look like a New York bagel emoji, right? That has a Unicode representation. Okay? Yes?
So to make the symbol go above the letter, you have to put it
Before.
the letter that you want it to be.
Exactly. Exactly. So as Zara was saying, if you want the accent in that case to be above my E, I would put the E first and then put the accent. Okay? So, yes, in my head. All in my head. No, there's a link I'll show you first very soon. Yeah. There's a source for it. Yeah. So as I said before, so a character could be one or more Unicode scalars. This is a Unicode scalar, right? So here, that's a Unicode scalar. Example of Unicode scalar, right? Okay, So, yes.
So if you wanted to, you could literally put a code behind every single letter in your string.
It depends on it depends on what you're after, right? You don't want to confuse your users, right?
I did for Tiffany, I put an accent over the I in
Yeah, you could do that, but I don't think that's a valid language, right? You confuse somebody like, what language is this? Okay, so I know French. Oui, 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 oui. Okay, so we said a character could be one or more Unicode scalars. Here we have one character. Do we agree that the E with the accent is one character? But here we have two Unicode scalars. We have the E and we also have the accent. Okay? E has its own representation of a scalar. Let's see what that looks like. If I go to the internet, the interwebs. Mr. Rogers. So E here has a Unicode scalar. It's 065. I will, if you're nice. No, I'm just kidding. I will, for sure. So here we have E. And let's run our code again. Oh, look at that. Thank you, brownie points. Okay. So what does that have here? So we still have, as you saw, I replaced the lowercase e with its Unicode scalar representation. I got the same outcome. Okay? If you all want to write in Unicode, feel free, but I don't think we would want to. But 0065, that's it. Forever and ever, that's the representation for lowercase e. Right? Uppercase E has a different code. That's why that's why they're not equal. Even if they're both E's, the Unicode compliant values are different. I think it might be 20 parts of 20. Let's see. Yeah, something like that. So normally it's like 20 counts apart. So in that case, 65, it's 45, right? Okay. So we've seen what Unicode scalars look like. Let us go ahead and let me slack it out to you first before Tiffany gets mad at me. Right, yes, indeed. Okay, so there we go. I slacked it out. We could have fun. You could search for stuff by name here. I could search for bagel, for example, maybe. Not bagel. Let me blow that up. Bagili. Look, I found bagel. All right. Should I get us hungry? Okay, so this is a bagel. If I take that code here, let's see what our bagel looks like. Bagel. Let's see what we have here. So we got our bagel, right? Cool. So that's again a Unicode representation of what a bagel looks like. So that's an international standard. Yes. No, but you can make your thing move. But no. But yeah. I mean, no. Later, not now. Let's not get carried away too much. In unit, we'll make things move, but not now. Okay. So we've seen Unicode scalars. We've seen counting strings. We've seen for loops on a string, how to iterate through a character. How to iterate through a message. Cool. All right, great. We've seen combining scalars, by the way. This is combining a scalar. Where's the example? This is combining scalars here. Combining Unicode scalars. We've seen that. Obviously, not all scalars are combinable, but those are combinable. They make up one character. We've seen comparing, for example, my E here I could compare my E. Where's my E? Let's compare, let's do some comparison. So comparing Unicode scalar with character. So if I have my Unicode E, for example, or lowercase e, right? And we have our E character. And we say if Unicode lowercase e equal to E character, print they are equal. Run our playground. And indeed they're equal, right? Even if they look different, right? But remember that Unicode representation is that same E representation. Yes? Hello? Yes. Right? So we went to our website, we got our Unicode character, our Unicode representation of lowercase e, and they should be equal. Because that enables us to go to the website and put in whatever we want here. For example, our lowercase e, and it finds lowercase e, which is 0065. So they should be equal when you compare them. So we could compare those. Very good.
Oh,
Yes?
that code is already active code. Is that why you added that an extra E at the end?
Extra e at the end.
Over-
Oh, this one here?
No, for the.
This one? What line number?
Am I looking down?
What line number? What are we talking about?
So you said let Unicode lowercase. Oh, lowercase e. Okay, got you. Equal. Okay, never mind.
Good. No worries. We are good. Clarification is good. No. Not at all. Okay, let's get into the beautiful things. Maybe it is, maybe it's not. But it gets complicated from here. All right, buckle your seatbelts. Accessing and modifying string. Let's have a constant called programming language. And it's Swift. Why wouldn't it be Swift? Great. So we have a programming language. It's called Swift. That's a literal string. We haven't accessed arrays, but you probably access arrays in JavaScript or similar, right? So an array, for example, we have here. We have an array of fellows. We love arrays of fellows. Fellows are awesome. We have Kelby. And we have Stephanie. Right? Somebody was asking about count earlier. If we were to run fellows.count, what would be the value? Right, everybody? Fellows.count on array, you could have a count on array and give you the items in that collection. So I think it was Chelsea I was asking about that earlier. So here we could just say fellows.count and get 2 here. So if we run it, we get 2, right? So far so good, that's good. I'm showing you arrays because to access arrays is different from accessing a string. To access an array, for example, if I want to say first fellow, I could simply say fellows, use subscripting. The square bracket here is called subscript. And I put the value 0 here. Which fellow will I be printing? Fellows at index 0. What fellow am I grabbing? Kelby, right? Everybody sees that? Again from JavaScript, right? So arrays start with 0, right? So in that case, it's 0, 1. If I want to access Stephanie, it would be subscript 1. But here, this is first fellow, and I just run my first fellow, and I get Kelby. Everybody with me? Okay, so arrays, accessing arrays is pretty straightforward. If you're coming from other programming languages, it's similar. But if I have my programming language here, I want to access, in that example, I want to say get the first character, S here. We were to assume that we could just index into it, correct? We were able to use a for loop on it, correct? So we have the same assumption that, hey, why not index into it using a subscript? 0. That should work, correct? But no, the compiler is already complaining. We barely did anything. Subscript is unavailable. Cannot subscript string with an int. See documentation. Thank you very much. So, go back up. That's why it gets a little complicated. It would be super simple. I'm in Python, right? You could do this. This is legal, right, Matt? Matt? Yeah.
Wait, if it were to be done in Python, what exactly is the computer?
That would not be an error. It would just work.
What and it won't happen?
It would return S.
Oh, as in S is 1, W is 2, I mean is 0.
Yeah.
Is 1.
Exactly. So it would be able to subscript inside that string, right? But this is not Python, sorry. But we still love Swift. Yes, sir. I'm trying to access the first character in the string Swift. In that case, the first character is S, uppercase S, but now the compiler said I cannot subscript using that syntax. So I need to do something else, which is fun. Maybe. All right. Cool. So we have an error. We can do this. We want to access our first character here. The goal is to access our first character. So access the first character in Swift. What would be the first character? S, right? Awesome. So that's what we're after. So let's fix this. This does not compile. If you see this, does not compile. Okay, so what are we going to do about this stuff? All right, so let's first create some sort of constant variable, call it first index. And we use our programming language variable. And on it, we use dot syntax to say start index. Now start index, you see the type? It's not an int. It's type string.index. Only works on strings. Some protocol. We'll get into protocols. But here we have string.index. We don't have an int. Right? That's why you cannot do subscript 0, subscript 1. So now we asking the string, give me your start index. The string has a start index and it has an end index. Okay? So here we say, hey, just give me your start index. So right now, our variable first index has start index. Everybody with me? The only way you could subscript into a string is using the type string.index. This is a valid type string.index. If you option click on it, it says string.index. Do we see that?
Yeah.
All right, cool.
That's another
Type.
index.
The variable, so programming language dot start index is a property on this string. Every string has a start index, very similar to when we had count, right? That's like a property on it. It tells me like, hey, give me your start index. Wherever your start index is, give it to me. So we have the first index. Everybody with me? So let's create a next variable called first character. First character, we have access to it now. So we could say programming language, the string we're concerned about. Everybody with me? Yes? Is everybody with me still? We're not in the crazy part yet. We're getting there. Oh, you see that? Oh. So now we could subscript using first index. The compiler should be happy. Now I want to print first character in Swift, well, first character in programming language is first character. Okay? Go ahead and run. And now we have our first character. Was it work? Was it too much work? Was it easy enough? That was a lot of work, huh? Yeah, I know. Strings. We love them. We hate them. We love them. So that's how you access a string, by using string.index. Okay? That's how you access it. Yes, sir.
So that start index only returns the first character.
In that case, it doesn't, the start index doesn't return a character. It returns the position of where that character is. We have to now go and access that position using the subscript syntax.
How would you get the F?
The F. We'll get to the F with an offset, even more things. Yeah. So the first step we did, let's go back again. The first step we did, we could do everything in one line, guys, but it gets really complex very quickly. Do we see that? Do we see that? So we broke it up. We're like, hey, we want the first index. We're interested in the first index in order to get the first character. The first character is S. We all agree? Yes. So we broke it up. We said, hey, programming language is the variable name. It has a string inside of it. So we say, hey, string, on any string, by the way, any string, you could say, get me your start index. So here we say in programming language, get me your start index. It returns us its start index. So now we have first index. First index is of type what? What type is it? String.index. So first index is of type string.index, not an int. So the only way you could subscript inside that string, only way to subscript into a string is using a string that index value.
Why did you specify that as mine?
Because with arrays, you get an int, right? When you say 0, we access in 0 or 1 or 2 or 3. So we're able to access arrays using integers.
Oh,
But maybe I'll remove it for now because we haven't seen arrays. I'll just remove it for now because we haven't seen arrays enough to know the context of that. So first index is of type string.index. Here, we know what that is. Only way to subscript into a string is using a string.index value. This is subscripting, right? Subscript this. This is subscript. Okay. Only way to subscript into a string is using a string.index value. This is what we have here. Now you could get the character and be happy. Are we happy now? We have our character.
okay. So
Yes.
just to review, right? So when we do let first index equal program language and start index, that's telling us, okay, we want to go into the string to see what's in there, right?
Yeah, we want to get the first character.
Okay, and then, but, so,
It only gets us the first position in the string.
okay, and then, for let first character, so it wouldn't work for a second or,
We have to use offsets,
okay.
which we'll see as well.
Okay, cool. But then after, so once you say, okay, I want to get into the string, and I want the first letter of the string, then you have to say that for first character, again, for first program language, because it's still split. You already asked for the start index, but you're telling us whatever that start index is supposed to be, put it into here so that I can see the first character.
I think you have two things a bit mixed up. So you could use a for loop to iterate through a string, right? You get all the characters, you're done, right? What we did earlier for, where is it? So earlier we had a for loop here, and we went through it. We just printed the characters, correct?
Yeah.
Here we explicitly want to access a specific position.
Right.
This is the way to access it. Like you have an array, I want to access a specific fellow. I say I want the first fellow. I say 0. Gets me Kelby. How can we do that in strings? That's the question, right? How can we access the first character in the string?
By doing dot starting.
The only way to access that first position, to access that first character, is the start index.
All right.
That gets it.
Opening the door, and the next one is actually taking in and taking it out.
Exactly. The next one is accessing it with the start index itself, with the index itself. Okay? Anybody else? Clarification? Clarification? Greg? How you doing? No questions yet? Okay. Questions? Okay. All right, cool. So this is start index. Now, if there's a start index, there's a stop. An end index, right? There's an end index, right? There's a start index, there's an end index. Great. Now let's see what that looks like. I want to access my T in my Swift. Where's my Swift? I want to access the last character. I want to print out the last character. Everybody with me? I now want to print out the last character. How do I do that? Walk me through it. So I'll create some variable, end index. Walk me. Programming language. So far, so good. Dot. End index. Very good. Right. So far, so good. Okay. We'll have an X variable, right? Called last character. So far, so good with me? Programming language, right? And then we use subscripting, right? And then we say end index, correct? Okay. And now we print last character. What should we see? T, right? Let's see what's happening. Wow. Fatal error. String index is out of bounds. When you thought it was right there. Okay, so end index is not what we think it is. Yes, we have to offset. So Ameni is getting places really quickly there. Ameni said we have to -1. So there's a way we have to offset. I'm sorry? So end index is not what we think it is. End index is part of string. We don't have access to it. It's the way, it's like a delimiter, very similar to end line in a new line in print. All strings have an end index. But that end index is that index before the last character. Yes, sir?
So, like, if you would let index equals the count, so like a JavaScript.
I'll show you how to do it using indexes. There's an offset that we could do. So as Amini was bringing up earlier, we could offset something, or we could go before an index. We'll use the before index syntax to go before the end index to get that character. Okay, a lot of things for you guys. So strings. All right, so let's see. So end index is good. We still want that. But last character does not get us, we can't access it with end index. So let's do last character index then. So last character index is yes, it's back and forth on why do they do this, but it's, yeah. So now we want to say index, where are we? Index before. Programming language dot index. I'm running out of space here. So let's go back here. So type in programming language. Let me get rid of this so I can get more space and see what I'm doing. So we want to get the last character index. We agreed that end index is not the last character index. Did we? Okay. So now we're using programming language. Type in programming language. Type in dot. Start typing in index. And let's go through what we have. So start typing in IN, and your screen should populate with all the index cases we could use, correct? Okay, so the index we're looking for is index before. So we want index before an index. So select index before. Do we see that? Make sure it's highlighted and press enter. And where it says before colon, you want to type in an index because we have that variable already. We have that variable right here. Everybody with me? So programming language dot index, it brings up the options we have. We select the index before an index, that's the index we want. It's a bit complicated, guys. It's one of those topics. So index before an index is the character index, that last character index, that's the one we want. So now we have last character index. We change our end index here on line 67 to last character index, very good. Right? Come on, autocomplete. And now we should get our expected last character, which is the T. Do we see that? Let's put some better messaging in here. So last character in programming language is last character in programming language is. Okay, so run that again, and let's digest it a little bit. Okay, so we have our first character in Swift is S, and our last character in Swift is T. We have to do a bit much more work to get the end index because the end index character is not what we thought it was. End index, we don't have access to it. It just gives us the point to the last index, but we have to offset it or we have to use a before. In that case, we use before end index, get me that position. I have that position, now I could use that index to go ahead and subscript using my programming language variable to get my last character. Questions? Yeah. Julia.
So when you use like engineers, if you lost like last letter of C, it goes to Y, and there's no empty space before RC. What is this last here?
So the last, so example, we have Swift here. Everybody can see? So we have Swift, we have start index. This is valid. This is good, this gives us what we want. But end index does not point to position T. End index is somewhere here. Right? I'm sorry? Yes, that's where the string ends. It lets the compiler know that's the end of it. We don't have access to it. There's no character there. What we could do is say end index, get me the index before you. The index before me is the position at T. Everybody with me? Not the space, not the quotation, just something inside of Swift. Yeah, exactly. Just lets the compiler know that's the end of the that later on. Exactly. Next question? Yes, sir. There might be a use case where I don't think we have public access to that use case, but you could take a look at it. But our use case pretty much ends at, hey, I want the last character. It depends. Maybe you want to shift things around. Maybe you have some algorithm question that says, hey, switch the last index with the first index, or some complicated thing like that. It could be, yeah. So knowing how to manipulate a string is very important. Because you could have any question where you have to know how to use whatever we learned so far to solve that problem. Whether it be your own application or an interview question, but knowing how to manipulate strings is very important.
I know there's a difference. I know that the way that we did with the string interpolation is that for last character, we put last character in
I like to do things various ways. This is valid. You could put quotations through the whole thing. That's also valid. Okay? Knowing how to do it different ways is very important.
That only work if quotation before
Yes. And then the comma and last character.
the comma is necessary.
Yes, in that case. Okay, cool. So we saw how to access the first index or the start index. We saw how to access the last character via the end index. Now let's see how to create a range to access characters in a string. You have a question, sir? Yes.
Yeah, my Excel error on
What type of error?
my error on what we're doing right now.
Okay, so one of the ideas we'll walk around and see what your screen is currently doing. Cool. Thank you very much. So, okay, let's move on to range. Range of indices in, let me grab a header here. Headers are flying away. Come back. All right. So, range of indices. Making a range of indices or making a range using indices. We'll see what that all means. Maybe change the heading. Okay, what does that mean? If I have, let's create a different string, for example. Let's create alphabets. That's a better one here. So an alphabets constant. A, B, C, D, E. We have our alphabets here. We got a question. Print out the first 6 alphabets, not using a for loop, but using string indexing, right? How do we solve that? That's the question, right? Obviously, you could use a for loop, but the question says do not use a for loop. And you want to access and print A, B, C, D, E, F. So how do we do that? Okay, let's go ahead. We know how to get the start index. So alphabet start index, for example, is alphabets. Let's start index.
Wait. Have we done this in a for loop? Because printing the first 6 of, you've never done that before.
But you can, with all the knowledge you have. Actually, let's do it. Let's do it. So if we're doing it using a for loop, so using a for loop, print out the first 6 characters. All right. Oh, our alphabet is gone. Okay, cool. So we have our for statement. So for character in alphabets, right? Print character. Currently, what does that do? Currently, what does that do? Right? According to 1, it prints all the characters. Do we agree? Right? So now we need a way to be like, hey, we got to 6, we are done. Thank you for bringing that up, Tiff. I'm able to show us something else we haven't seen yet on a for loop. There's no way currently to keep count. We could have a counter somewhere. We could have a counter like, var count. Don't type that out. We could have var count equal to 0. And in here, we could increment this by 1. This is valid. And when it's 6, just break. Or 5 if we start from 0. Does everybody see that? So this will be valid, right? Actually, go ahead and type it out, and then we'll do it using enumerated. So go ahead and do it like that first. So here we are coming in. We have this variable count here, or counter. We have a variable counter. It counts. It counts from 0, 1, 2, 3, 4, 5. I'm sorry? Wait. We want to end it when we are at 6. So we want to say, we counted the thing here. If counter is less than 6, we want to go ahead and print. We want to go ahead and increment. If counter is less than 6, 5 applies, 4 applies, 3 applies, 2 applies, 1 applies, 0 applies. Each time, increase my counter, else break. That's one way we could do it, right? So counter is 0. It comes into the for loop. It checks this condition here. Counter is less than 6. Do we agree? Do we agree? Yes? No? Okay. So this is true. It comes in here. It prints A. It increments the counter by 1. So next time, it does it go in the else? Does it go in the else statement? No. It goes back to the for loop, right? Exactly. It goes back to the for loop. It increments this. It goes to the next character. Comes back. It prints B, prints C, prints D, E, F. Right? So far, so good? Okay. And when we are greater than 5, it breaks. If we come here and the value is 6 less than 6? No. So it goes to the else, it breaks out of the for loop, and the program ends. So here we can just put a statement, for loop has ended, just to give us some visual cues here. And let's go ahead and run this. All right. So in our console, we have A, B, C, D, E, F. So basically, we have the knowledge. We have the tools already. It's more about just practice, right? Like, how can we learn? How can we do everything together we learned so far? We saw a for loop before. We saw an if before. Print, counter, variables, if-else statements, breaks. All those come together to make programming work. Yes? You could use a where, as we did yesterday, as opposed to doing the if, right? But I want to show us a different way to do it all together without creating this outside variable. But I think, let's keep this example here. There was a question in the back, question in the front. Move up, error messages, up here. We haven't done, so we have our alphabets. Do you have your alphabets above your 4? If you don't have your alphabets above your 4, it's going to compile error for you because it doesn't know alphabets. So is your alphabets above your 4 statement? What's the error message? So we'll circulate and we'll double check your error message. Okay, so this is one way to do it. So far, so good? So you're given a question, print the first 6 alphabets, boom, you're done. Yes? Okay.
Sorry, I don't remember reading that B and C.
B and C. Did you put the alphabets correctly, sir? Do you have A, B, C, D, E, F? Or do you have A, B, C, B, B, B?
I have the same, it's just we need to finish 2 lines before we have the
Genesis is with him right now. Okay, so let's see the other way, and then we'll keep going. All right, so here we're using a for loop. And let's use using a for loop and enumerated. Print the first 6 alphabets. Enumerated, yeah, we'll see what that looks like. All right, so we have our alphabet, same thing, we'll use that. So for character in, remember you can name this anything you want, by the way, guys, the variable, yes? Yes? Okay, so for char in alphabets, or you could say for alphabet if you want. Alphabet in alphabets. Alphabet singular, right? Cool. So now we're going to use what's known as enumerated. Enumerated basically is this value that you could use on a collection. It's a function. It gives you the ability to gain access to an index, the current index in that particular collection. So the syntax looks like this, right? So instead of saying for alphabet in alphabets, if I want to access the current index that the alphabets is in, I use enumerated on it. So it gives me access to the index. So it starts from 0. Index here starts from 0. So now I have access to an index. I could be like, hey, index when you whatever, break, and you're done. Everybody with me? That's fine. We'll do it again. So let's type it out again, what it looks like. An index could be any name, as before. So here, alphabet, I'm going to go back, Belinda, and then we'll come back to the question. So here, this is our regular 4. Everybody okay with that? Comfortable? So far, so good? Unless it's alphabets, right? You can go through a single alphabet. Everybody okay here? Okay, so we want to gain access to an index. An index is the current position of the alphabets in the string. If I am in Swift, my current position when I start is 0. Everybody with me? I'm going through a collection, current is 0. I go through the for loop again. What's my next position? 1. And? 2. And?
3.
And?
4.
Okay. So that's what the index gives us. What does it look like? How can you get access to that? You have to use that enumerated on your collection. And that returns you the index, which is the first value, followed by a comma, followed by the value itself. So the index is an integer. Index is an integer. Alphabet is whatever type your collection is. Those are both variables that we name in ourselves. I could name it I and J, right? I could name it I and J. I is still an int. J is still an alphabet. Exactly, is that index. Exactly, it gives us access to that index. If we don't need access to that index, we don't do enumerated. Okay? Now, we can keep writing code. Question. Enumerated gives you access to an index or a collection. That's a function there. A function. Anytime you see, we'll get into functions, but anytime you see an open and a closed parens, that indicates to us it's a function. That function doesn't take any parameters. Okay? Like print, we could have parameters or we could not have parameters in it. Okay, so now we have index here, and we want to print for sure. So print as before. We're going to print our alphabet. Okay. And here we're going to say if index is greater than whatever, 4. Is it 4? Yes. 0, 1, 2, 3. What do we want? 6, right? No, 6? 0, 5. Okay, so if it's greater than 5, or if it's less than 5, rather, less than 6, 0, 1, 2, 3, 4, 5, less than 6. So that gets us 5. So if it's less than 6, you want to print your alphabet. So far, so good? Else, break. So here we have index starts at 0. So we have 0, 1, 2, 3, 4, 5. And 6, does 6 go inside the else block? I mean the if block? No. It goes inside the else block, right? So it goes inside the else block and it breaks. Everybody with me? Index is less than 6. Index starts at 0. It goes 0, goes back to the for loop, iterates 1, 2, 3, 4, 5. Every time it does one of that, it prints what my alphabet is. When it gets to 6, it no longer goes into my if block, it goes into the else. Everybody with me? What was that? Questions? Comments? Okay, so now we can run. Many ways to do things. Above what we did, let's go back through it. What we did above, we had to declare this extra variable.
So we using the numerator, you don't have to declare.
Exactly, exactly. Yes, this is the way you want to submit code, not with that extra variable. Okay? So when we're talking about like best practices and everything like that, anything you create extra space, extra memory, extra everything, right? So you want to keep what's inside the language and use what the language gives you. The language gives us this index. If we use enumerated on it, no reason to keep track of a counter. Do we see that? So 2 ways to do it. Option 2 is preferable.
So basically, when you have like for index alphabet, each like each the index is basically like the position of the number.
And it starts at 0. And it starts at 0.
So when you put the comma alphabet, that's basically like this.
I have 2 variables.
What's next to?
I have 2 variables.
What's in this location?
I have 2 variables. I have the where it is, and I have the what it is.
Okay.
Everybody with me?
Okay.
The index implies what position. The alphabet implies what alphabet. Okay?
If it's not, even if it wasn't the word alphabet and it was a word, like what position, what letter?
The first variable is always the position. So now let's use some string interpolation so we could see what that looks like. So here I could say alphabet at index. That's going to give us more information. So go ahead and run it. So now we see A at index 0, B at index 1, C at index 2. We get the picture? Yes? Mr. One.
Do something like index 1, 2, whatever, and more.
Where am I? What do you want me to do?
Like use a mod operator
On index like this?
No, on index in the if statement.
Okay. You want me to change this? What do you want me to do?
Mod 2
Mod 2 equals
1.
1, so it's odd, right?
Okay, just print it.
and then just print it. Okay. What are we after here?
Kind of only print certain values.
So that's odd, right? Odd indices?
Yeah.
Yeah, you could do odd indices,
That.
right? Where are we, actually? Index 0, odd indices. 1 second, let me run this again. Did you stall on me? 1 second. What's your question? Like, you could do multiple conditions on the index there.
Okay, that's fine.
Like, but I need to know the question. Like, what are you after? Our question was just to print the first 6 characters.
Right.
But you could say, hey, print all indices in the alphabet.
So I can go A, C.
Yeah, you could skip. You could do odd indices as well. Yeah. In that case, that would be in the else statement. We'd have to have an else like block to print something.
So then that makes
Let's keep it simple. I really don't want to lose us here. The objective was just to print the first 6 characters using a for loop, using enumerated. There's a lot of new things already on top of it. But yes, that if could definitely be something else. It could be a mod, like get me the even indices. It could be get me anything after 10, as far as like the alphabets after 10 or before 20. You could always elaborate on your conditions or add on to your conditions. Cool? Okay. Yes, Tiffany?
Is it possible that maybe, I think what confused me a little bit is that, like the alphabet and alphabets, because the constant is alphabet.
Okay, let's change that.
So we could use that.
Let's change that now because some people, like for me, I've been seeing that stuff for like a while. So I'm used to like naming things that way. You will get there as well. But for sense of not confusing you more, let's change the name. So instead of alphabet, we'll call it character. Okay, does that help us? Does that help us?
Yeah.
Okay, so I'll change character here. Again, whatever variable name you're comfortable with, it's fine. And let's just run again, make sure it's still working. Okay, so we're still working, we changed alphabet, right? But again, 2 years down the line, 3 years down the line, you'll be saying alphabet in alphabets. Alphabet implies one alphabet in the alphabets, right? Fellow in fellows. But for now, if naming helps you better understand, go with whatever naming makes you better understand. So far, so good? Okay, cool. So that takes us here. What's that? So midday check-in is after lunch.
Okay.
Cool? Sorry we did not go through that, but midday check-in is after lunch. I know you want to check in already, but a lot of content. I'm sorry? Okay. Actually, we're very close to the promised land. We have 2 things. If we do the ranges, we could see what multi-line looks like, and then we have enough to do the labs. So we have 10 minutes. We could do it. Break. So good question. If we don't have the break here, in that case, once we get to that condition, we want to stop the loop. That's why we put break here. Once, assuming like you have whatever, you have 1,000 objects to look for, and you want to look for a certain object, right? I want to look for a mini in like 1 million users, and I go through this loop. The minute I find a mini, do I want to continue looking for a mini? No, I want to just get out. In that case, it would, so that would be not useful there, right? But it shows when we get to that condition break, right? Like it's more visual, but yes, we could. But for example, I'll keep the break. So for example, if I put a print statement here, and say print print going through alphabets. I print going through alphabets, and here I say break. Emily, you with me? Okay, so let's run this again. Run. So here, it's going through alphabets, right? A couple times here. And if I didn't have the break here, it would still print going through alphabets. Exactly. Like if I do not have that break here, it goes through the entire alphabet. Right? So run again. You see? So right now I'm going uselessly through the entire alphabet. So in that case, you want to break and be done. Does that help? So assuming you have more code, yes. Thank you for that. I'll keep it there so we know why. All right. I'm sorry? Oh, like where I am now? Okay. We have it. I think we do. Dinosaurs. We got dinosaurs. To what? Ah, Francis. I see you. Okay, so I slacked it. Cool? Okay, let's us do, what's that question? Okay, cool. 2 more topics. I think we could do it. We'll come back to it, but I want to show what it looks like. So we're not like, oh, I've never seen this. We'll come back to it. But I want to show us. Actually, let's stop here. I'll just show one thing and then we'll stop here. I'll show you guys what multi-line look like and then we'll come back to indices tomorrow. So multi-line strings. I want to show you multi-line strings. So multi-line strings, for example, I could have a string here called multi-line, for lack of a better word. Multi-line string. A multi-line string, this is the syntax for it. You have 3 quotes on one line. You press enter. You have 3 more quotes on the last line. And embedded in those 3 quotes, literal, you put your string. In that case, I will say, hello, hello, hello. Get it? Hello. And I will go ahead and I have a print statement here saying multi-line string and print it out. And I have hello, hello, hello as a multi-line string, right? So you could have a case scenario where you have a string that does not fit on one line. You have multi-line strings there. What the syntax for it is, again, 3 quotes on the first line, 3 quotes on the last line. The quotes are by themselves. You do not put the quotes together with the string. That's an error. And embedded in those 3 quotes is your string. You might want to draw some pixel art or ASCII art or whatever you want to draw in a multi-line string, for example. What's that? You could put, let me show you 1 second. Let me get the URL real quick. String. Where is the URL for this? So this is a multi-line ASCII art, right? I could grab this and put that in my multi-line string. Well, let me close this a little bit. Xcode, preferences, go to default dark, make it look nicer here. And if I was to print now on my playground, Any day now, Mr. Playground. Okay, so here I have rendered ASCII art, right? So for your project, whatever, if you want to add some like, UI or graphic to it, you could use ASCII art and add it as a multi-line string. Okay, we saw how to implement a multi-line string using the 3 quotes. Any ASCII art, you put it within those 3 quotes. Let's create a next one here. What the bird? ASCII. So this is 1 second. ASCII ART. ASCII. ASCII. I blow it up. Let's go up here. 1 second. Let's get one more, and I will show you everything you need to know here. Okay, so I'll create one more for the love of Swift. I'll slack it out. I'll slack out the links. So here we have Swift bird. I made it smaller so we could see the visual, but I'll make it bigger for us to see the code.
So like if we would like instead of putting we could put an image and then use that like at the end of our name.
Yes, yes,
What pops up at the end.
exactly. Like loser, come again or something. I mean, you're not gonna do that to me though. But all right, let's see what this Swift bird looks like. Right? So you could add graphics to your command line app, right? Whichever way you want there. Let me slack out the things. So I slacked out, did I slack out the bird one? Yes? Did I? Yeah, you can. You could type them out yourselves, like whatever word you want. ASCII art. So I slacked it. I did. You saw it? Let me slack the second one. So this one, I mean, yeah, we could go nice and fancy here. And this is the second one, or vice versa. Cool? All right, so that ends our part 1 for strings. Tomorrow we'll just cover what we didn't go through with indexing. Actually, it might be even better to see what indexing looks like again. You might see in the lab some of them asking indexing, but again, it's due tomorrow, so that's like perfect. So we're able to go through indexing tomorrow a little bit with offsetting. We haven't seen offset, so we'll go through offset strings tomorrow and whatever else we did not touch. Cool? Does that work for you guys? Great, thank you.